Hi there, you're welcome back to my channel, and in this video I'll be taking you through the sandwich theorem. So this is an important theorem used to find the limits of some special trigonometric function. Okay, so what does this theorem says? In our previous lessons I've taken you through the different types of limits of different types of functions. Okay, so we continue by taking this nice theorem in this tutorial. If this is the first time you've been on this channel, kindly subscribe to support, and please don't forget to watch this video to the end. Okay, so it says if g of x, a function g of x, right, is less than or equal to a function f of x, and this a function f of x is also less than or equal to a function h of x, right, where x is near x naught, so where this x is near x naught, then the limit as x approaches x naught, right, so this is near this, right, so the limit as s approaches x naught of the function g of x is equal to the limit as s approaches x naught of the function l of h of x. So see, we are talking about the endpoint. So the condition is if you are having a function f of x in between two functions g of x and h of x, and where the limit of h of x and g of x are the same, this and this are the same, and they are equal to L, then the function of what f of x as s approaches the same x naught will also be equal to L. That's what they are saying. So the sandwich here means that it is in between two functions of equal limits at the same point. Take note, it's in between two functions of equal limits approaching the same point, meaning that if you want to find the limit of the middle one, then it's obviously what the limit of what either of each of them, which is equal, right? So that's the concept. So I have a problem here for you to understand the concept. It says find the limit as s approaches plus or minus what infinity of sine x over what over x of sine x over x. Remember. So now let's see how we solve this problem. Okay. So to solve this problem here, what you should have in mind is that the limits as s approaches positive or negative infinity of sine x or cos x or tan x does not exist. Does not exist. Take note. So limit as x approaches plus or negative infinity of sine x does not exist. Take note. On that note, how do we solve for the limit of this? How do we find exactly the limit of sine x over x? Do you just go through and say it does not exist? No. So what do? We use a sandwich theorem so that you know that sine x is having what? The magnitude, the highest what magnitude to be what? To be equal to 1, then the least to be what negative 1. These are the ranges. Every sign of any function will either give us a maximum of 1 or a minimum of what negative 1, which you should take note of, right? And at this point, if I divide through this inequality by x, what am I getting? I'm going to get something like 1 over x less than or equal to sine naught x less than sine x over x less than or equal to negative 1 over what x, right? Then at this point, if I'm to find the limit as s approaches infinity of each of these components, so limit as x approaches what plus or minus infinity of 1 over x, what am I getting? Of 1 over x, what am I getting? So I'm getting what 1 over what infinity, positive or negative, and obviously this will give me what 0, right? Yeah. So if this gives me 0, what about limit as x approaches positive or negative infinity of negative 1 on x, right? So obviously this is also negative 1 or positive or negative or infinity, which is also given as 0. So meaning that the limit as x approaches positive or negative infinity of our either side of what our inequality are all given as 0. By sandwich theorem, what does it say? So you can see that f of x is now what sine x on x, right? And it's in between two endpoints of equal what limits, which is what 0. Therefore, the limits as x approaches plus or minus infinity of sine x over x is also equal to what 0, and that is the sandwich theorem, right? So without solving this or without manipulating this using the sandwich theorem, we should be able to find the limit as x approaches plus or negative infinity of sine x on x. Wherever you see it, don't forget to what make it equal to 0. Okay, don't forget to make it equal to 0. All right. Yep. So this is the end of our tutorial, and please don't forget to like, subscribe, and share.